Hello! In this second video, we're going to be taking a look at piecewise functions, which is the second topic featured on Thursday's quarterly exam. So with piecewise functions, we have seen them in the past. It's literally breaking up a function into several quote-unquote pieces, or saying, hey, I'm going to take this section of this graph, this section of this graph, and kind of put it together on one coordinate plane. A big thing with piecewise functions is the right-hand side of what you see below, this right here. What are we talking about with this? It does look a little unusual at first, but it's basically our rules. It's saying where to start and where to stop each graph. Okay? And we refer to that as our domain. Okay, it's where or how we know which values to include for each section. So let's start. I like to usually get these going by making a little table. I call them mini tables for each function. For the top function, -2, some people panic with for whatever reason, but it's just simply a horizontal line through -2. And I'm just going to include the two endpoints. If this is a straight line, I do not have to include all the values in between. And evaluating y is very easy, because it's always going to be -2. The only other thing I have to take into consideration is what type of points should I have here. My graphs are not going to contain arrows on the end here because of the given domain. It's saying to start and to stop at a specific point. Okay, so at -5, I'm going to represent this point with a closed or filled in circle. And at -2, I'm going to represent that with an open circle. Okay, how do I know the difference, or how do I know which one to use? I'm really looking right here. This tells me to fill it in. It can equal -5. And this tells me to leave the -2 open. What you don't want to do is treat the open circle as this. Like, hey, it can't be -2, so I'm just going to go to the next number and use -1. Okay, you're kind of missing out on all the decimals if you do that. And it is incorrect. Okay, you're missing out on all the decimals in between -2 and -1. So simply plot that point. Don't make it more confusing than it has to be. Plot that point and then just treat it as either open or closed. Okay, and now graphing these. 1, 2, 3, 4, 5, -2. Closed circle, and at -2, -2, open circle. That's what I was saying earlier. By me plotting the endpoints, I'm hitting the points in between anyway. Doesn't save me a tremendous amount of time, but in some cases it can. With the next function, we have a quadratic. This can be a little tricky with piecewise functions because we're used to an algorithm with quadratics of saying, hey, let me organize the table this way, let me put the vertex in the middle. But in this case, or with piecewise functions, we can't do that. We still have to follow these rules, regardless of where the vertex is. So notice I'm going from -2 to 4. Why am I not doing the trick here with the endpoints? Why can't I just put 2 values in my table? Because this is not a straight line. Okay, I might plot 2 points and want to connect them like this, but for all I know, the graph could look like this. Right? So we really need all those in between values because this is nonlinear. So for evaluating or finding the y values, type this into your graphing calculator and just simply copy down the results from the table. Next to -2, you should have -9, -2, 3, 6, 7, 6, and then 3. Okay? Let's make a little note with our circles. -2 is included. That's right here. And 4 is not included, or 4 is open. Okay, so at -2, -9, I'm going to plot that. -1, -2, 0, 3. That's 1, 6, 2, 7, 3, 6, and then 4, 3 is open. I want to plot that. So you see, we almost get like want to say half a parabola, but like maybe 3/4 of a parabola. Yeah. Obviously connecting these can be a little tricky. Okay, and we get that. So notice I have my open circle on the right, filled in circle on the left. And like I said, it's unusual. It wasn't vertex centered, so it's not going to be symmetrical, but this was the given domain that we were told to graph. Also notice it is a function, even though it looks like there is some overlap. And that's usually the question they ask. If we look at part A here, it says, find g of -1. So what does that equal to? If we go to our graph, at -1, we're looking for where the graph is included, which would be right here. Okay, and that's going to be -2. If it had asked, let's add another little practice question in here. I think this is what I originally meant for it to say. G of -2, we have a decision to make. So someone might say, all right, once again, -2 is right here. It could be this, or it could be this. Which one are you going to pick? Are you going to pick that first top function in blue or the red function? And the answer would be the red function on the bottom, and your answer would be -9. So why did I choose that one? We're talking about included versus not included. Even though we kind of plotted a point there, there's not an actual point on that blue function at -2. It's right up into, but not touching -2. -2.1 it is, but not at -2. It's not on the graph, therefore we can't say the answer is -2. The vertex, we can find our vertex with our formula, the -b over 2a, or just by observing the table. It's not going to be in the center, but you should still see it. We see it at 2, 7. How am I picking that out? You could either look at your graph and see at 2, 7 that little peak, or like I said earlier, the symmetry that you notice. How around 7 you see 6 and 6, and then 3 and 3. Okay, so this is an example of a piecewise function, and we're graphing a piecewise function, and some of the follow-up questions that can result. So just to recap, mini tables, deciding what type of circles or points to use, open versus closed. Even for the quadratic, making a table of values, a little unusual, but follow the domain and use your calculator to fill in the rest. And that's everything. So thank you for watching. If you have any questions, feel free to let me know, and I'll do my best to help out.